Hello, hello. uh, Let me know if you can hear the sound. So, thanks for coming. This is a tutorial live stream for Houdini, a weekly Houdini tutorial live stream, and this is a 153rd episode. And the topic for today is to create a kind of a role network using L system-based setup. I already have some questions from Rafael, and thank you for the super chat. I am not going to use L system on Houdini, but I'm just going to use Vex instead to implement the simple L system based setup together with the solver. So that's my plan, and what you are seeing right now is the result that I'm going to create. So first of all, I'm going to create some procedural landscape with some flat area where you want to create some city role network. And what I'm going to do is to place a initial road will be treated as a highway, and I'm going to make it grow over the space using some randomness together with the L system based setup. So the highway is going to grow, and you're going to have some branchings to create some city based network. And you get something like this. So this is just a road into the optionally I wanted to create some buildings, but I didn't really made it that point, so maybe next time. And this is kind of based on a algorithm explained in one of the posts that I found interested, which was written like 10 years ago, but I think it was really interesting, so I'll show you what that was. Let me check. So this is the idea that I got from where it explains how you can create a role network just like you see in my post, which is pretty cool. It's written in CoffeeScript, a variation of JavaScript, and so you can kind of create a bunch of like city network procedurally, and also some buildings as well. Pretty interesting. And it does some explanation how you can create these network using L system. So I'm going to explain how I kind of implemented the similar idea into Houdini. Okay, so that's my plan. And if you could go to this code section, you can also download the code for this thing. So it's a great reference, I think. Yeah, I do got a lot of inspiration from this code, so that's a reference. All right. So the plan is, let me just write some okay, so you Yash don't have some ideas about the L system, but L system is more of a recursive system which can be used to make something like fractal patterns and so on, like tree like shape. I don't really know about the good tutorials about L system, but maybe you could anything you do in solver is kind of a recursive system, so once you know how to deal with solver, it's just easy to deal with the L system. And I'll maybe you might grab some ideas about how L system works in this live stream, hopefully. Okay, so before getting into the actual codings or implementation, let me just briefly draw some steps that I'm going to do. Okay, so first of all, I am going to create, what's this? I don't want the pencil, but pen. Okay, so first I'm going to create a kind of area where I want to create a road network, which could be any kind of shape. And what I'm going to do is to create some mask informations on top of this surface, where it can be set as a populated area. Okay, so I want to create a populated area so that the road will be created on top of those areas. Okay. Next, I'm going to create a initial highway network starting with 2 lines somewhere on the middle of this space where the populated area is placed. Okay, and that's the initial setup, and I have to define a bunch of like parameters for probability, since I'm going to use some of the randomness in order to define when to turn, when to create the branches, when to go to a next a road, when to connect with the next road. So first thing that I want to do is to grow the highway network that you have placed initially, and I'm going to create some of the road to grow a highway. First thing, if you have a line like this from start to end, the one probability you want to have is to just just extend the line by adding additional lines to here. Okay, it's pretty easy. You just go straight. Another probability you might want to have is that the line will bend a little bit and go to some other space. And in order to define which road or which steps you're going to choose, it's been defined by whether the point at the point of this new highway endpoint is highly populated compared to the one on the bottom, which bends to the other place. Right? So if this point N is more highly populated, then this one will be chosen. If this N is more highly populated, then this rows will be chosen. So you're going to use this information to decide which way you should go. And the angle of this bendness will be defined randomly, probably around minus like 15 degrees to 15 degrees. Could be parameterized for that. Okay. Another setup. You also might want to go to the other directions, like perpendicular directions for the highway, to have some branches. In this case, you don't want to make the branching every time, but maybe at some point where the population is highly dense, you might want to give a chance to create a branch going that way. So in that case, you're going to create some probability, like let's say 5% of times you go in perpendicular directions, either left directions or right direction. And Also, another probability could be chosen, maybe 10% or 90%, 10% by 90% to choose whether this road will be highway or just a normal road. Okay, so it could be highway, 10%, could be a normal road, 90%. So that's the steps for the highway. Then for the normal road, after you have got some normal road being created, let's draw this in red. Then you want to do the similar things just like you did on highway, whether you want to go straight or you want to go bend it. And also based on some populations, whether you want to bend. I realized I am not going to bend actually the the road itself, the normal road, but the normal road kind of always goes straight. Just go straight 180 degrees. And also you might want to give some chances to go to a perpendicular directions. In this case could be more high probability than the highway, so maybe 40% or something. Okay. And that's pretty much the rules, and if you continue doing that, you're going to get a bunch of crosses along roads along the highway, something like that. And at some point there's going to be some collisions between the normal road and highway, and that's where you also want to solve some intersections to clean up the mess, which you see it's somewhere around here. Okay, sometimes you might want to like connect these lines, or you might want to just have some separations and so on. So there are some connections here, there are some splits here and so on, but you don't want to have too dense like intersections, so you also need to solve those problems. Okay, so that's the whole step to create a kind of a neural network based on the L-based system. And in terms of the L system base, what I mean by L system is that you're just going to continue looping this process over and over again, time-wise base. And that's pretty much it, recursively. Okay, so enough with the idea. Let's try actually creating this from scratch. Okay, you do have to code a lot with this setup, especially inside the solver where you're going to create branches, and also some collision detections or intersection cleaning is also important with this setup. So I think these are the two parts you might want to check it out. Okay, I mean, as always, I'm going to upload the files after the live stream, so you can always check the files later. Okay, so I am saying that it's based on the L system base, since the base idea is saying like that, but actually what I'm kind of writing in Vex is more of a recursive system. Just a simple recursive system, just like you create a fractal shape and so on. Okay, so don't worry about the L system grammar itself. Okay, so let's do this. Let's go to here, and first of all, let's create some base geometry plane in order to define the population. Could be any things, but Would be cool if we see the landscape in 3D, maybe, even though the road network itself is 2D. Could be a good idea to use 3D plane, like a landscape plane, as a base, because it will be a bit prettier. So let's do that. So first of all, I'm going to create a grid with enough size, or well, let me use height field first. No. Let's create a height field. Then create some landscape shape by using height field noise. Okay. Which is the easiest way to create a mountain-like shape. Okay. Let's also create some flat space where I want to create some road network to this. So to do that, I'm just going to use a simple vex. I'm going to use a height field wrangle to flat the area where the height, the y value is less than 0. So I'm gonna clamp it to 0. So, oops, not the p, but height is equal to height and max 0. Oops. Okay, well, it's also controlled some of the areas to make it a bit more organic, and you could also raise up the overall mountains by increasing the height right here. Yeah. Okay, something like that, maybe. I don't know. Okay, let's try with this. So, so let me check the comment. Used in L system in Cinema 4D. Just played around a little, and it wasn't that hard. The syntax there is slightly simpler than in Houdini. I've started working on L system with the Vex, where I still can input my command like else. That's cool. Where I type it grows should grow. Didn't make it yet, but go where it's typing. I didn't make it yet, but that sounds very cool. So I guess the way that I'm going to use in this setup, in this live stream, is not really really related to L system. Since I'm not going to use any command for any, just pretty much code-based recursive setup. So it will be possible to convert some of the code to a command, probably, but I didn't have much time to go for it. Well, although the base idea is pretty much the same written right here. It will be interesting reading this, as well as some papers explaining this procedural modeling of cities written in 2001, which is the one this guy referred to, which was the original paper explaining how you can use L system in city network. So yeah, one thing you might want to check it out. Explain it here. Yeah, I think it's pretty well written. So this guy just modifies some of the explanation written in the paper in a more easy manner. Okay, so I have created the flat surface. Then let's also convert it into a mesh, so it'll be easier to use for me. And right now the geometry is a bit too big, so let's go back to the grid and resize this height field with this grid. So I'm going to match the size of the grid of the height field to the grid, which is 10 by 10 size. Okay, and check scale to fit and make it to X for a scale axis. Okay, now it's being scaled down. Let's also bring the bottom plane, the bottom of this height field to be placed on 0, y equal to 0. So going to the match size, I am going to change the justify y to minimum. Okay, so it will sit on top of the ground, the floor, XZ plane. Okay, now next let me increase a resolution of the space grid, which I am going to use it to set up a population. Let's say 200 by 200 is enough. I think might be too much, but let's say, well, I'll just go with 200 by 200. Now what I'm going to do is to copy the height information from the second input and use that height information to convert it into kind of a population information. I mean, it's not really related to population, but I'm just guessing that the flat area is more populated than the higher area. So I'm just going to copy, I'm just going to use a point wrangle, connect the height field converted meshed into a second input, and for each point I'm going to create intersections upward to calculate the height on a corresponding XZ position. Meaning, first of all, I'm going to create a intersection positions and UV as a variable, create an intersect function applying to the second input, and starting from a at P for each point on the grid. Just move this a little bit downward so that I'll be able to get at least one intersections for sure, and going upward for array. Then you'll get the variables filled with the export variables, and as a result you should be able to get a intersected positions inserted into this variable from this plane, and by getting the y coordinate of this interpositions you're just going to get the height. So the height will be interpositioned by y. Now let's and I just want to have the flat area, so if the height is pretty much close to 1, close to 0, then make the population to 1. Just going to use a fit function to convert the height, which is from 0 to 0.01 to 1 to 0. Just have some smoothness on the edge. This could be a little bit less, more. So I'm just gonna parameterize this one just to see the changes. Let's say starting with 0.1. Oops. And change it here. Okay. Now let's see the gradation of this height color or population color. So the name of the attribute is population, so let's copy this value, paste it here, and change this to something like green. So things like this. So green areas is the populated area, and the black area is unpopulated area, which is using the information of this height. Okay, so what I want to have is to have some connection road network created on top of these green areas. Okay. Although the highway could go across the black area, maybe making some tunnels or going over the mountains and so on. Okay, but for the city road network, the road network, I don't really want to cross to these black areas. Okay, so this is the initial setup for the plane. Next, let's create an initial highway line somewhere on this plane. So I gotta make sure that the highway will be created somewhere on top of this green area. So let's try to, well, could be just on the center, or could be retrieve from the current like green areas, whichever you like, but I'll just place it on the center for ease. And let me check how I drew it. So first of all, I'm going to create a line. Okay, and I'm also going to create a controller, and by using a null node which contains all the parameters that I want to control later, such as the basic edge lengths of the highway, the base edge lengths of the normal road, and also some probability for each choices that you're going to make during the solver, during the simulations. So first of all, I would like to define the highway lengths as well as the normal road highway. Normal road lengths. Okay, so for the highway length, I'm going to define it by 0.1. For normal road lengths, I'm going to define it by 0.05. Okay. I'm going to copy this highway length and paste it to the length of the line, since this will be the initial line for the highway, and since this is forward into the y axis, which is not good, so let's forward it into x direction. This direction also define where it's going to grow, so you might want to also control the directions. If you're going to place it like x-axis, it might just going through the walls like these. If you place the highway network on this axis, z-axis, you might going to go through these areas. So it will change the behavior by changing these angles. So it's pretty important how you define the direction, the initial directions, and the position. So this could also be parameterized. But for now, I'm just gonna leave it to the center and x direction. Okay. Next, also Since the basic plan for the road to grow is to just look at the endpoint and whether you want to grow, whether you want to extend the endpoint to the similar directions or not. So if you want to go for the other directions, you also need to have additional lines created on this side so that you have an endpoint right here. So what I'm gonna do, just gonna mirror this so that you'll have two lines, both one has endpoints on the side, hopefully, and you also want to kind of fuse the points on the middle. Okay, so the first line on the right will have a starting point on the middle, then endpoint on the right hand side. The second lines will be the starting point on the middle and the endpoint will be on the left hand side. Okay, so that's it. Both lines will grow in the different directions, opposite direction. Okay, so let's also set some group to these two lines to define that these are the highway, not the normal road. So I'm going to create a group, call this highway. Okay. Now, additional stuff that I want, that this guy was using, is to use a queue-based system. That is probably because he wanted to control the speed, how fast each road grow. So the highway has a less queue than the normal road, so that it will grow faster. Although I'm probably not going to use that system, but I'm just going to simultaneously grow the road because I'm using Vex, kind of a multi-threaded system where you can approach to every primitive in one step. So, which is a bit different to what he is using. It's using more kind of brute force way to control the grow the line one by one. So a way that I'm going to do, and the way this guy is using on this website, is a bit different. I'm trying to make the result similar as possible, but actually the whole algorithm is a bit different. So please be reminded for that. So I'm going to go with these. I think this is at the least information that I need for the initial setup. I think. Let's try. If not, I'll just go back and try to solve. Okay, I think I also need to create an additional group just to know which line is going to be processed during the solver. I don't want to process all the lines for every time, every step or every frame, but I only want to grow the one that needs to be extended. The one that's already been extended or finished extending, then those ones should be skipped for the process or for the calculations. So I'm gonna name these as Q. Okay. So for now, two curves are in the Q group, which needs to be processed for the extension. Okay, so that's pretty much I need for the initial setup. Let's create a solver, and let's also connect the reference plane where you have a population informations as a variable, as an attribute, I mean. Okay, so let's go inside the solver and actually write the growth system. Okay. First thing first, So I am going to use a primitive wrangle so that I can simultaneously access to each edges and grow each edges which needs to be extended, and that is on inside a queue group. So I'm gonna filter the edges by queue, and all the edges which is in the queue should be grow in some manner. So first of all, first thing first, let's try to grow the highway to the extended direction, I mean to the straight directions. Just as I said, there are two types of growing for the highway. One is to just go straight toward the directions where you have as a previous line, or just try to bend the curve in some random angles and and find out which point as a goal have more high populations. Now, a little bit of problem with this initial population population setup is that everything is one inside a green area, right? So I might want to have some like noises within these green areas to have some kind of a random directions to give some random directions for the highway to bend. Okay, so to do that, I'm going to add additional randomness or the noise value to this initial population value. So to do that, I'm going to create additional point wrangle. I'm going to introduce some noise function subtracted to this initial population. Let's try that out. So population minus noise based on at p by multiplied by some scale smoothness, and let's also fit the function from 0 to remap the function from 0 to 1 to 0 to some max value. Let's see what would happen. So for the scale, so you see some gradations being applied to this base map. Okay, so I'm gonna make the maximum to 0.6, and the scale could be, I don't know, maybe 0.4 for now. Let's try changing this later to see how the highway connection will change, the highway direction will change. Okay, going back. So I have the primitive wrangles, and from the input to I have the grid which has the population information. So let's connect this to second input right here. Okay, so here it goes. This is where you're going to create a bunch of long line of codes. So, but let's try to make it as simple as possible. Okay, so first of all, let's have some variables. One is the highway length, and the normal road length. And you can just bring the parameters from the top network, just copy this, go back to a solver and paste it right here. I'll just paste the same thing here, just rename it. Okay, so this will be the length for each edge for the highway and length for each edge for the road, the normal road. Okay. Now let's see if I am currently working on the highway or not. So if imprim group highway primnum. So if the current primitive is inside the highway group, then I would like to process something. So in this case, I want to extend the line from the start to using the start to end directions as a base direction, and whether going straight toward that directions or just trying to bend with some random angles. Okay. So in order to do that, I need to create two goal positions to check whether which one has the higher populations. Okay. So let's do that. And first thing first, let's get the start point and end point of this primitive, which could be done outside a filter. I mean, inside the conditional. Can I make this a little bit smaller? Yeah. Okay, so first of all, let's get the point position, point numbers from each primitive, and each primitive is just a line, so it only has 2 points. So you're always going to get 2 points as a array by using prim points for your own primitive number. And pt1 is the starting point, pt2 is the end point in this case. Get the actual vector value as a position. And calculate the direction from start to end by subtracting 2 vectors. And let's normalize it. Okay. Which could be used for either highway or normal road as an information. Okay. Now let's try to rotate this direction, which goes from start to end, by some random angles. So let's create additional parameters here. Highway angle, random angle. And normal the road angle. Which will be used for a maximum value for this randomness. Okay. So for the highway random angle, I want to create a value in between -15 to 15 degrees, which was the same setup as this guy is using. And for the normal road, I'm just using 3. Or is it? Oh, wait a minute. No, actually not. Actually, you are not going to bend the normal street, I realize. So let's just delete it. But instead, actually this highway random angle that I have just created is for the straight direction, and the second one will be for the cross section, the cross perpendicular direction offset. So I'm just gonna go perp and straight. It's pretty long. variable name, but so I have to delete this one. So for the straight, you have 15 degrees offset. For the perpendicular directions, you will have like 3 degrees offset. So that's the rule. Okay. And for the normal direction, I mean for the normal road, you have 0 offset, either for straight or perpendicular direction. Okay, so let's create some let's create some extensions. So you need to have 2 goals to decide whether you want to go straight or bended. So the first goal, let's call this n plus 1, is a current end position plus a direction, which is a straight direction, multiplied by the length of the highway, so h length. So that's the first goal. The second goal is to convert this rotate these directions by randomness in between -15 to 15 degrees and use that to define the goal. So to do that, I'm going to create a rotational matrix by some random angles with some seed. And plus some additional value here, and which is in between 0 to 1, so you might want to remap it so that it'll be in between minus h angle and h angle. Okay, and since this is in degrees, I need to also convert it into radians. Okay, now the axis is y direction. Okay, now after I have created the rotational matrix, you also want to rotate this direction. So let's create a new vector and just rotate the direction by the matrix. Okay, now the direction has been rotated by some random values in between -15 to 15 degrees. Let's create a new goal starting from the endpoint, going to the bended directions, multiply by h lengths. Okay, now I have 2 goals, either this one or this one, which is these 2 points position. Now what I want to do next is to check the population on this position, and I want to choose the higher populated area for the direction. So let's check. To check, you need to kind of collect the population information from the second input, which is coming from this grid here. So you can get those population information by something like UV sample. So you want to get the population as a float number using P as a sampling value. Just use add P, not add P, sorry, but n plus 1, which is the first goal here when you want to go straight. Okay, let's also check the second one. Popu2 UV sample population n plus 2. Okay, so this is for the bended direction. Now you have two informations. Let's check whether which one's larger. Okay, so if the population 1 is larger than population 2, then you want to go straight. So the this position should be chosen. So let's create a variable called high pass, starting with 0, and update the high position, meaning highway positions, with population n plus 1. Okay, else update the high position with n plus 2. Okay, I hope this makes sense. Now, now that the higher position's been chosen, let's try to create a line. Let's create a point to this position and make it as a additional edge. Okay, so let's do that. And I also want to make sure that this new position is on top of the grid, the plane. So if it's outside the plane, you don't want to create a new one. So in those cases, you can just skip the code. So additional conditions you want to check is if xyz dist to the second grid using high position is less than, like, if less than like 0.001, which means the point is on top of the plane, then in those cases you can create a new point on this high position, high pass position. So let's do that. Let me see. So in this case, first of all, you're going to create a new line. So I'm going to say new int new edge is equal to add prim poly line. Okay, and maybe you can have initial point as a pt2, because that's the end point and that's going to be the starting point for the new edge. Okay, then make a new point, new pt on the high position right there, and add it to the polyline. Or you can just bring this beforehand and then just set new PT right here. Maybe this is better. Okay. Oop. Got some errors. Yeah, no functions for rotate. Oh, what did I do wrong? Rotate. So I have maybe the number of parentheses. Let's make sure that the random is float value. So float, because sometimes it's being treated as vectors in some context. So, well, maybe this parenthesis was wrong. Okay, oops, I do need a parenthesis here. So I have float value, which is in between 0 to 1. I put it here, remapped it with the fit, converted into radians. Okay, how's this? Nope. No matching functions for rotate, int. Wait a minute. Forgot. This has to be math. Sorry. Alright. So, it seems like it has been bended a little bit, so probably the populations right here is higher, maybe? Okay, so let's see. And the things that I want to check is whether I can run this over to grow the edge over time. Now, one thing I notice is that this part is not growing. So let's see why. You can see it's not really growing. And why is that? It's supposed to grow on both sides. It does have 4 primitives, so maybe it's going to the same direction somehow. Okay, I realize I did something wrong here. Wait. So this is a primitive point. Let me just comment these out for temporarily and make sure that I'm getting the right position to position 1. So I'm gonna make these numbers shown up. Let's try to create a new point at position 2 so that 2 points, one of the points being created here, one of the points should be created here. No. One of the points kind of created right here, so it's pretty much wrong. I guess that is because of the process that I did here. So seems like the starting point of this primitive is not starting point is not right here, but seems like this is the starting point for this line. Let's use a sort to check it by vertex order. Doesn't really check. Okay, let me pick this one right here. And let's check the starting point and the end point by vertex order. Okay, so yeah, as you can see, actually actual order of this point of this primitive is that starting point is from the left hand side, so that's wrong. Okay, so to fix that, I'll just flip the second one using reverse. Okay, hopefully this will fix. Now let's check this again. Sort. Point sort to vertex sort. Okay, so seems it's been fixed. Okay. So hopefully going back to the solver. So yeah, you're going to get endpoints being created right here with this test. Just delete it. Okay. Okay, looks good. Looks good. Okay. So that's good for the initial start. Now next, what you want to do is to apply this Q group to a newly created lines and remove the Q from the original curve. which you could do it right here inside the code, but I suggest do it outside the code later for the later process. So what I'm gonna do is to create a new group, apply to this new edge for a later process, especially for the intersection collision detections part. So print group, I'm gonna name it as TQ, temporal Q, to a new edge. Okay, so if you look at a geometry spreadsheet on the primitive side, you have this is the original curve that's been extended, and this is the newly created edges. Okay, and these edges does need to have some optimization later. Well, currently it's okay, but if you're going to have a lot of intersections, kind of need to fix those. But for now, it's a simple, just a highway line, so it's fine. And what I'm gonna do next is to delete group delete outside, extend road network wrangle, and delete the queue. Okay, so which will delete all the queue groups. And what I want to do is to transfer this TQ to a original queue group. So group promote. I don't know if it's gonna work on the same primitive. Let's try. So convert from primitive to primitive. The group name is TQ, and the new name is Q. Okay, so it's being converted, and the reason why I named it Q is because it's being used in this filter right here, and the reason why I'm using TQ, the temporal Q, is because I want to especially process these newly created edges somewhere in between right here to solve some intersection problem. But for now, this is fine. Okay, so hopefully this can already being run for highway extension. Let's check it out. If I play it, oop, stopped. Maybe something's missing. What else did I? Okay, forgot to set the highway group. So let's also set a highway group to the edge that I have just created. Set prim edge 1. Okay. Right, so if I run it, some weird road network's been created, and if I compare the network with the guide that I have here, it somehow just using a population value, but inside the dark areas it's not really following, I'm just bending randomly. So and it's a bit hard to see. Let's translate it upward a little bit and merge it with a base plane. Okay, so I cannot really see if the population value has been used or not, because you don't really see the, well, you do see some straightness right here, but most of the time it's going bended even inside the black area. Black area is supposed to be just 0, but since I'm creating these randomness subtracted to the population, there are some changes inside here as well. So what if I bypass this? Let's see what happens. So it goes a bit more straighter. I mean, looks also okay. This might be a little bit, might have been a little bit too effective. Let's say 0.2 and 0.2. Okay, well, maybe something like this. And one thing I don't really like at this point is these since this is a highway network, but it's kind of wiggling a lot to me. Looks a lot too randomish, especially these changes right here. So I am going to kind of control the randomness a little bit, so that you'll be having more 0 degrees than 15 degrees. I'm going to create some like deviation, or going to create some how do I say, a probability that you'll have more probability to get you'll have more probability to get the 0 degrees than minus 15 to 15 degrees. So that most of the time you get these degrees, and few chances you get these high bend in degrees. So that's what I'm going to achieve. And I already have a code to do that, so I'm just gonna copy paste that, because it's a bit long code to write. So let me see where I have written it. Okay, going back inside the solver, and I'm going to create a function beforehand like this, random angle alt, and this is the degrees, and this is the random seed. And so first of all, you're going to create a you're going to create a value of this angle using power functions. Then you're going to use some randomness to diffuse the value in between minus limit angle to the plus limit angle, and as a result you'll get some distributions like these as a final angle. You have less chance to have minus 15 to 15, and you have more chance to have degrees on the 0 degrees with these. I just copy paste the base functions from this code. So check that out. Okay, well, let's check. Let's try to use this to set the random angle. So right now I was just using a random as it is right here, but instead of using rand, oh, not here, right here. Okay, but instead of using a random functions like these, I'm going to use this one. So let's copy this function, and where is it? This one, somewhere right here. The first value is the angle. Angle is h-ang in degrees, and the seed is this one. I'm just gonna copy it, paste it right here. Okay. So, let's see what would happen with these. I play it. You see that oh, this is funny. the lean is the randomness a bit become a bit more narrow, trying to avoid a high turn, but this is a bit funny. I don't really want to have a rotation like these. Am I doing it correct? Well, let's try to control with these noise populations. Let's also apply some max value so that the minimum is always 0, so that the black area will be treated as straight as possible, as much as possible. So let's see. Okay. Well, I'm not sure if you can really see the difference. I mean, you do still see some wiggle here, so maybe it wasn't that effective as I thought. Oh, anyway, I'll just go with these. Okay, so that's for the straight curve. And the next thing you want to do is to create a cross curve, a perpendicular branch for the highway. So for some percentage, I want to create a branch for each of the highway edge, going to the left hand side or the right hand side, where the population is dense enough. Okay. When the population is dense enough, I want to turn it to the perpendicular directions and continue going to that directions. Okay, using the same rules that I have here. So to do that, I need to give a conditions, just like these. So let's say I have 5% of chance to turn either on left or right, and within that 5%, I also want to choose whether it will be a highway or a normal a road. Okay, so let's just try to create a highway first. So 5% multiplied by 10%, which was pretty small percentage, 0.5%. You'll have a chance to turn and becomes another highway. Okay, so let's do that. And let me check how I implemented it. So let's open up the code editor. Sorry. So this is where I'm creating a highway, okay? Oops. What did I do? And within these conditions, I also want to create a turns, like going to the left hand side or right hand side. So let's do that. So let's see how I do that. So let's create some new parameters to check the probability whether you could have a turn or not. Okay, so highway prob. as well as you do have a normal probability, I guess. Did I? Let's leave this for now. Let's just give a high probability parameters. In this case, I wanna set it as a 5%, meaning 0.05, to make a perpendicular direction edge. So within this conditions, I'm going to create a new conditions somewhere around here. Let's create the comment here. Straight. Okay, and for the next step, create a not sure about the spelling. Okay, so perpendicular branch. So if the probability is if the random value is less than the probability, then create a branch. So I need to create another randomness. Rand at p plus seed plus some random value is less than, what was the name? hprob. It's hprob. Then create a perpendicular edge. Okay, and you also want to check if the population is high enough. So let's have additional parameters to check the populational threshold. How do I call this? Float h pop thresh. Highway pop thresh. Okay, I'm getting an error. Let's just set some values here. So the highway probability, let's maybe set to 0.05. Highway pop thresh, let's say 0.1. So if the population is more than 0.1, then you can create a perpendicular edge. Seed could be any bin. And I am getting an error here. Where is it? Multiple declaration of variable and pos 1. Really? Wait a minute. I think I did something weird here. Some unnecessary code has been copied to somewhere. Damn it, sometimes it happens. It's a bit hard to see. Did I? So this has been copied. Okay, which part? Right here, I guess. Okay. Okay, so yeah, I have these conditions, and this is 0.1, 10%, no, 0.05, so 5%. And also the next step is to create a perpendicular directions to actually set the goal. For example, if we are looking at this edge right here, you want to go this direction, this direction, or either this direction. Okay, so first of all, let's give another randomness to pick either left or right. Okay, and create a direction to that direction. So another randomness, if rand at p plus chf seed plus additional custom random value is 0.5, so 50% go to the left, 50% go to the right. Let's create the integer called left, and if it's within this random conditions, convert it into 1. Okay, now let's get this original direction, the edge of the original direction, which is already being calculated right here. So what I want to do is the similar things that I did, just as I did here. Rotate this directions by some angles. So this could be functionalized so that I can repeat using the same code with less lines. So let's say, what's the output that I need? So for this one, I just want to get the final output, which is this one. So let's create vector value to get the rotation position, and as a function you need an input. First of all, you need an angle for sure, and you can just put the randomness inside the code. So is it? Yeah. So let's set the angle for the first input, and let's also set the seed, because we're using some randomness here, and the direction you want to rotate. So okay, and the original positions that you want to add the direction and multiply by the length. Not sure if I should increase everything in one function, but let's see. If it's too much, I'll reduce it later. So position, and what else? Position, you do have directions and lengths. Okay, it's a lot of inputs. Now let's copy this, paste it here, and this should be replaced by angle. This, okay, you cannot use at p inside the function actually, so you probably just need to replace everything right here with seed. Okay, it's fine. The directions good. Replace this with pause. This will be fine, and this is length. Okay, and gotta need to return this position as a result. Okay, so hopefully this will be replaced with these. Let's see. So the first value is angle, and you have a seed, and you have a direction, you have a position, and the length. Okay, let's just check if this is gonna work before getting into this code. I'm gonna comment these out. Just wanna see if it's gonna work by playing this over. Oh, something is weird. It's getting slow here. Okay, I think something is wrong. Huh. What is it? Oh, look at these. Something wicked is happening. And why is that? Whoa. Okay, so I'm using a queue. And I'm deleting the original queue and transferring TQ to queue. So as a result, I should not be having tons of queues. Okay, so that's something's weird. Okay, that's pretty weird. Let's go back to the first step. Maybe something's wrong here. Okay, so why do I have multiple? Huh. Maybe I haven't deleted some of the code that's being copied somewhere. Oh, this one. Huh. Okay. I don't know how it happened, but somehow I have some ghost here. Duplicated ghost. Okay, so should be fine. Let's go back and check this again. Okay, looks good, looks good. Okay, now going back. Now that I have a functions, it'll be a bit easier to rotate with randomness. So let's create some random value. Vector and pos is equal to rot pos. The angle that I want to use is a 90 degrees rotated plus some probability, some random offsets, in this case a n-ang, or I should change that by p-ang. So in those cases, actually I should not write like this, because it's just going to use every angle for randomness. I cannot put 90 degrees here, so instead I'm gonna apply and add new parameters like base angle and offset angle, and set the angle to base angle plus some random angle using a offset angle as a parameter. Okay, so for this one, this could be 0, and I'll copy this. And for this one, the base angle is 90 degrees, and you're going to use a P angle offset, which is 3. So for the perpendicular degrees, perpendicular rotation are going to create a 90 degrees plus or minus 3 degrees as an offset. And that's the seed. Let's change this to something. And the direction is fine. The position too is also fine. The length is also fine. It's the highway length. What's this? Implicit cast from vector to float. It must be talking about this one, I guess. For the seed. Yeah. I could make it vector. Okay. Now, let's see. Let's run the code for a while and go back to the solver, and let's try to create one point at this point, so that to check if the point could be created at perpendicular directions. Do I see it? Actually, this is inside the probability, so you gotta wait for a while to see the changes. Okay, let's go back, play it. Okay, as you can see, I do see some points being created. Now, what I want to avoid is having these points where there is no populations. So to avoid these points being created, I need to also check the populations where the point is going to be created. So going back to the wrangle. So this is the goal. So I need to check the population just as I did here. So let's copy this place and check the populations, and also I need to set the degrees 90 or minus 90 based on these conditions right here, the left. So if it's equal to 0, I could say it's 90 degrees. If it's 1, then let's say make it minus 90 degrees. So I'll just use fit, or yeah, I'll just use fit. The left, fit 0, 1, left from 90 degrees to 90 degrees. So if it's 0, that's minus 90 degrees. If it's 1, 90 degrees. Okay. That's that, and I got the population from the second input. Yeah. And using this to check the threshold that I created as a parameter. If it's more than 0.1, then you are now allowed to create the perpendicular edge at that point. So let's copy this here. Check. Let's check. So play it, and there you go. You are now avoiding the points being created inside the dark areas, but only on the populated areas. Okay. And you okay. Should be fine. Now it's time to create an actual edge. So hello everybody, thanks for the comment. Thanks for saying that. So where was I? To create an edge, I already have a point position, so just as I did right here, I just need to create a edge. Now this could also be parameterized, but Let's see if I need to do these more than 2 times. In that case, it's better create it as a function. For now, I'm just gonna copy and paste, and in this case, the name is npos. The new edge, new pt, pt2 to new pt. Make it as a TQ, fine. Make it as a highway, yes. Okay, so this is where you want to set either for highway or either for normal road. So right now, if I make every crossing perpendicular edge as a highway, that's gonna be quite busy highway. I mean, quite tons of highways gonna be created. Let's just check. Like that. Now, that's not really optimal, is it? So, gotta need to reduce the percentage how much the highway should be created. So right now, 5% of the times where you can create a perpendicular edge, it's gonna be chosen for highway. But among those edges, you also want to specify how much of the times it's been converted into highway or normal road. So I'll say that maybe a 10% of the perpendicular edge could be converted into highway, kept as a highway, and other 90% should be created as a normal road. So let's create a condition such as that. So how do I name it? H perp prov. It's getting harder to define the name. So another 10% chance. So let's copy this, go in here, and if another random value. Now I'm starting to think that this could also be functionalized. It's a pretty long line. Is less than h perp prov, then make it as a highway. If not, kept as a normal road. Okay, so let's see what would happen. Do we have a 0.1? Yep. Okay, let's play. I'm kind of wondering why it's kind of been rotating a lot like these. Is it because of these noises? Probably, if I bypass it. Yeah, it's better. Let's just not have these after all. Or instead of using noise, maybe use some random function. Would that change? Maybe a better. Not much changes. Now this one doesn't really do anything yet. I do want to see a chance to go on a perpendicular direction, so I need to check with different seed. Let's go back to here and change the seed. It's be a low chance to have these perpendicular edge. Nope, not a chance. Let's raise up some probability to like 20%. Nope. I am guessing that maybe I could just move the initial lines somewhere around here so that I have more chance to be inside a populated area, or just increase the populated area. Might be easier to solve. So go back to the initial landscape. Not this one. This one. How's that? Okay. So a little bit extended. Still. Change the seed. Wow. Let's change the probability to like 40%. Now that's a lot. And still no chance. Maybe in other words, I'm lucky. Okay. I'm starting to get too much. Now I should also create a condition so that these won't cross, okay? That's a part that I need to create so that it will not, I mean, maybe crossing like these is okay, but I should avoid having these like angles, crossings, and so on. So those part I think I do need to fix. No, I guess this is too much. Like, let's make this back to 20%. Oh wow. Let's let's see what would be a good idea. Let's just give some transform node somewhere on here and move the line somewhere around there. Rotate it. And let's see what happens. Okay, not bad. Well, let's move this a little bit to somewhere around here. Okay. Okay, well, not bad. So you do have one like lines being created, but before I tested, 10% was the good chances, so I'll go with the 10% for now. Okay, so now you have created the highway both for the straight extensions as well as the perpendicular branch extension. And if you check which ones is the highway and which one is normal, let's just color the highway, and I kind of need to make this a primitive. I'm going to wait a minute. I do need to make this, oops. I do need to have a point attribute right here, but for the coloring, I could promote the color from point to primitive, just so that I can merge together with the curve which being colored by primitive. So point to primitive CD. Did it go? I don't know. Maybe not. Why is it missing? Why is it missing the color suddenly? Is it the normal? Nope. Oh, forgot to make it point. Okay. So, looking at these, the red color displayed here is the highway, and the white is the normal road. So the next step is to extend these normal road. And this is pretty similar to how I did for the highway, but a little simpler. The normal road always go straight for the extension direction, and for the perpendicular directions, you're going to rotate by 90 degrees, maybe plus some offset. Yeah. Plus at the same angle, like 3 degrees. Okay, so that's the rule. So it's pretty similar to what I did for the highway. Let's just try creating it within the same code, within the same wrangle. So you already have a bunch of conditionals, but you're going to do the similar things. So the initial conditions that I have is whether the primitive is highway or not. So for else, which means you are currently walking on the normal road right here inside, and you are going to pretty much do the similar things that I have here for the highway to a normal road, with a bit of different values. First of all, for the straight lines, you're just going to use the straight directions, and that's it. And just check the population, and if the population is populated enough, you can go to that point. And the lengths, the extensional lengths for the normal road will be less than highway lengths, so which will be n length. Spell mistake. N length. And actually this one could also be n length if it's normal lengths. So let's fix that. So this is where I was creating a highway edge, right? And the way, actually I'm already setting a length right here, so well, let's just skip the connection part to the same edge length as the highway. And from here I will reduce the length of the city road, the normal road, to n length. And if it looks weird, I'm just gonna fix it later. Okay, and so this is the goal goal positions for the normal road extension, the straight extensions. And what I want to do is to check the population just as I did here. So population to that goal position, and if the population is larger than some threshold, which could be similar to this parameter variable, so in this case n pop thresh, let's say normal pop thresh, and I'll say same 0.1 for this one. I mean, we could always go back here to change the parameter to see the differences later. But for now, I'm gonna go with the default value, like 10% of the chance it'll, I mean, not the chance. This is the threshold for the population. So if the population is more than 0.1, then you can go to that direction. Okay, so what was the name? Npop thresh. So if the population is more than npop threshold, then you can go to that point, and pretty similar to what I did here. Create a point, create an edge, set the group, so on. Set the highway. I mean, this is not a highway, so you don't really need to set the highway. So add point, polyline, TQ to new edge. So this part could be repeated more than 2 times, so maybe I should make it as a function, probably. And what I need as an output is edge number, I think, in order to set the groups. Yeah. So let's make it function, shall we? And this is not PTI, this is PT2s, okay. So how do I do that? Int create edge. Okay. So you're going to need a position as a parameter, and also a starting point and end point. So starting point, well, end point is this one, so that's fine. And that's it, I guess. And as an output, return the new edge number. Alright. That should do it. I'm getting an error here. Reference to undefined variable PT2. Alright, that's ST. Okay. So let's copy this. Replace this one. First of all, hide pass. And PT2. Was it? Yeah. Okay. And replace this one. This case, this is and pause and PT2 for the starting point. It's fine. Whoop. Wait. Something. Got some problem with my display. Okay, it's being fixed. Okay, replace this part. Like that. And pause BT2. Yeah. Hopefully this is correct. Let me just check. Okay, and somehow the straight edge has also been created. Okay, so looks correct. And let me refactor some of the comments. Okay, now that I have a straight line going like this way, next things that I want to have is the perpendicular directional line for each edge, for each normal edge, obviously. So in this case, let's check with the color. So the white one has a bunch of edges like this, and I kind of want to fix these. I kind of want to have a perpendicular like chance to go left or right. Okay, so let's do that. Going back to the code, and I'm gonna give another variable to set the chance whether it can go to the perpendicular directions or not. When for the highway it was like 5%, but for the normal road you should have more higher probability, like 40% and so. And both way, left or right, could go both way at the same time. So let's give a normal perp prob. Now starting to have a lot of parameters, and let's set this to 0.4, a 40% chance. Okay. Now let's give some conditions. And let me just first check whether I'm doing the right, if I'm on the right track or not. I think I am. Yep. Okay. So let's create some conditions. Okay, so I am going to check both for left and right, whether it can go for left hand side or right hand side. So I'm gonna create a for loop starting from -1 to my +1. So we're going to have two iterations, either I equal to -1 or I is equal to 1, and use that to define the direction. Okay, by just changing the rotation degrees. Right. So similar to what we have for the perpendicular directions for the highway, I'm going to kind of copy these, paste it right here. Okay, and change some of the part. First of all, the seed, I kind of need to include the I value so that the seed will be changed for each iterations. Just change something like that, and the probability is using what was the name? N perp prob. Now, oops, maybe am I on the, okay, well, anyway, I think should be using the different name for the N perp prob, because H perp prob is being used for some other reasons, but actually the normal probability, it should be related to highway probability, so I should change the name. Let me change the name. Just gonna change this to n prov. Okay, it's not really important, but just to make sure that I would understand what it does. Okay, normal prov, sorry, change the name. Okay, sorry for that. So normal prov, let me just check the spell. Okay, and let's also change this name to nprov. So for ease of understanding, so this will be nprov. Okay, and this part I don't really need it because I'm calculating both sides. I already have a corresponding value like I here. Okay, and for the end pause, I shouldn't use that end pause right inside here because I already have it here. So let's call this pause, and rotating the value. In this case, I don't really need to use a fit functions, but just multiply 90 degrees by I so that I'll be able to get both minus 90 degrees and 90 degrees. I can use the same pang, which is 3 degrees offset. Let's change these seed. Multiply by I. And direction is fine. Cost is fine. Change this to n lengths. The population, let's call this pos, or yeah, popu populations to pos. Okay. Now for the threshold, I need a normal value threshold. Do we have that? Yeah, I have it here. So I'll copy this one. Paste it here, and creating a new edge is fine. I don't really need to set it as a highway, so let's skip that and let's see what would happen. So I am guessing that tons of curve is gonna be created, tons of edges gonna be created. Nope, actually not. Although it's getting slower and slower, so something is happening. Maybe some edges being created too much in the same area. Yeah, seems like duplicated lines being created, so I can see that it's not being rotated. I think I did something wrong here. We just reset. And let's check how it's growing. So, right there, where you're supposed to have a crossing, it's not created perpendicular directions but created on the same direction, so that should be the problem, and that's need to check why. So I was hoping that this part will create a 90 degrees rotated value, but seems not. Let's check. Oh, well, it does. It does, but oh, I needed to use the p-pulse here. Okay, that was the reason. So sorry for that. Going back, and let's reset, check the result. Okay, play it. Whoa. So as you can see, oh, well, that's pretty messy. So for a few seconds it's fine, but suddenly it just explodes because I'm not reducing anything right here, so it's just the edge is just going to increase in a vast amount of speed, and suddenly it just being crowded so much. So that's the next step. The next step is to reduce the number of edges being created, and also like combine these merged lines together and so on, and solve the intersection problem that you see all around the places. Okay, so let's do that. And I am also guessing that I might want to increase the chance for the perpendicular probability to 0.2, or no, not this one. No, this one to 0.1. See what happens. Let's skip creating a normal line for now. I just want to have more chance to have a crossing and a perpendicular directional curve. Okay, not bad. Not bad, but let's use the probability for the highway perpendicular directions. Okay, that's good. Okay, so the next step, creating a baseline is as good as we have right here, but the later process is pretty much important in terms of to constrain the lines to be clean, so that it doesn't intersect with other road and so on, to avoid these conditions like this. So let's try to solve that. So for the coding, this is it. This is pretty much it. Now the next step is, let's see, first thing first, let's go back to a little bit somewhere around here, and let's see what sorts of issues we have. First of all, for example, I am kind of introducing some bendings to a perpendicular direction, so there is a chance that there's some offset between the endpoints like this. Okay, so one thing that I want to do is to, if the point is close enough, I want to just fuse it for the first step. So I'm going to create a fuse and set some values right here to fuse if the point is close enough, so that it will be created as a corner. So for this value, you could still parameterize it. I will give a like 0.01 for this one, which is 20% of the the normal lengths. Is it? Yeah, it's 20% of the normal edge lengths. Okay, so let's check. So as you can see, those points being merged if the point is close enough. So that's good for one thing. Now another things that I need to solve is that if I look at the primitive numbers, you see that you're going to have a lot of duplicates lines all around the places. So you also need to reduce that as well. You don't really need to have a bunch of same lines as and you don't want to use those as a next extension candidates. So to reduce that, you can just use convert line so that all the duplicated lines will be merged like that. That's one thing you could do. And you also want to check which one is the one that's been extending in the current state. So let's give a color to check the primitive TQ. Draw it red. So the red part is where the curve is growing. Now currently I'm kind of changed the setup by adding the convert lines. I need to go back to reset and play this a little bit more. Okay, so let's see somewhere around here. And you can see that the outer edge is being drawn as red where the new edge is being created. So this is where the new edge is being created, and if you go follow it, you're going to see some other problems happening. For example, these intersections where the angle is too shallow, too small, and a bunch of intersections like these, pretty dirty. So we need to also fix those part as well. Okay, and especially when other rows being connected or being touching, you're going to have some messy intersections on those when it's being merged. Okay, so we need to fix those. So let's try doing that one by one. Okay, so a bunch of things to do. One thing I want to fix first is the one thing I want to do is to give intersection analysis to a current line state. For example, I want to kind of split these curve. If this curve and this curve being intersected, I want to have additional points being added somewhere around here on intersected points and split the curve into two for these two curves. So that will be easier for us to deal with unnecessary curves like these part and these part and so on. I don't want to delete everything at all, but just want to, sometimes I want to delete this part from this intersected points, or this edge from this intersected points. So there are some conditions where you want to keep one part but delete the other part, split by the intersected points. So to split the edges by the intersected points, the easiest way is to use intersection stitch. Okay, and use it for a convert line. And make this proximity tolerance small enough so that you won't get an artifact. Like 0.001 suit good for my case. It could be bigger if the whole geometry is bigger, scale wise bigger, but for this one it's pretty small in terms of the scale, so I'm using a pretty small value for the tolerance. And as a result, you will be having a stitch points there and there where you have an intersections. I'm kind of missing here. Oh yeah, I do have it. Yeah, something like this. Okay, that's cool. And the edge is being splitted as well. Alright, now I could, at this point, I could also apply a additional fuse so that it fixes some of the part where the stitch point and a intersected points being too close to each other. Okay. And by using a fuse, there's a chance that some of the primitive lengths become 0, so could be better using cling after this. So let's check. So after intersection stitch, you have 330 points. After fuse, you have 321 and points and 438 primitives. After clean, didn't really change, so that's fine. Okay. So after this, one thing you wanna make sure is to preserve the group called TQ. So previously it looked like this before stitching, but after you have did the stitch, the color kind of changes. As you can see, this part is no longer a TQ curve. Previously it was, if you check like this, okay, like this. So it's better you preserve the group informations after you have stitched. So to do that, I'm going to use Wrangle to copy the corresponding group. So this is a primitive group, so I'm going to use a primitive Wrangle. And connect this one to the second input. I'm just gonna search for the corresponding primitive which is on the same position. Now, because I'm using fuse, there's a chance that there's some offset, so maybe I should do this later. Okay, so I'm gonna do like this, and I'm gonna use XYZ distance to get the closest primitive, closest corresponding primitive. So XYZ distance to the second input with the current point position of the curve, which is the middle point position of the line, and get the primitive NUV. Actually, I don't really need a primitive NUV. I just need a distance. And if the distance is small enough, which should be on the same line, I can just copy the group from the second input. Or wait a minute. Or let me see what I did here. Well, actually, okay. One thing I forgot to do. Before copying the group, there's a chance that by using intersection stitch, you're going to have some, like, how do I say, a kind of a messy stitch. Well, I gotta show you an example, so I'll just copy this group for now. So if this is close enough, I am going to get the Q group, TQ group, imprim group, TQ at prim, and set prim group to the current TQ with this one. Okay, let's check if I color this. So it's correctly copied the group informations from the second input. Now, let's try connecting this right here, and by using intersection stitch, you're going to have some messy result at some point. So let's see if I can get that situations. Okay, I think I got it. And I need to stop it. So, okay, right there. Oh, I'm not seeing anything. Why I'm not seeing anything? Anyway, you see these long edge. This has been created by Stitch for some reasons. I don't know how, but unwanted edge, which is not really coming from the original any edge at all. So we need to kind of delete that situations, delete those infos. So to do that, need to see in the solver somewhere in 21st, 22nd. Okay, there you go. So to delete those, need to see beforehand how it looked like. So this was the previous conditions, and if I use stitch, somehow it creates these unwanted long edge. So I need kind of a need to delete it somehow. So to delete it, I'm gonna use a similar method that I use here to copy the edge. I could also check if the center point of this edge is on, center edge of this edge is somewhere on top of the edge on the original curve. And if it's not, then that means this is a unnecessary edge. And I could also check with the length as well. As you can see, this is pretty long. So in two ways I'm going to check it, and if it's not necessary, I'm gonna delete it. So I'm gonna first of all calculate the measure with the perimeter, then create additional primitive wrangle and doing the similar things, calculating the distance, and if the distance is small enough, that's fine, but if it's too big, meaning it's off the edge, off the original edge, that means you need to delete those. So remove prim. Okay, so it means deleted. And let's also create additional conditions. If the length is too big, you might also want to delete it. So if the perimeter is bigger than some threshold, just delete it. And for the threshold, it could be related to the edge lengths that you defined here. So the maximum length could be 0.1, which is the edge length of the highway. So I can copy it and paste it to the threshold, and maybe multiply by something like 0.5 for some offsets. So to delete the garbage. Okay. So that's one things you need to do beforehand. Now, after this, you could use a fuse. Okay. Okay, next, and you could then transfer the group. In this case, a oh, wait a minute. Should do it beforehand. And fuse it. Okay. Now, next thing I want to do is to remove the edge where the angle is too steep, too narrow, too small. Like for example, if you consider about the road, if the angle is too narrow, it doesn't really make sense. So maybe apply, set some threshold like 30 degrees, and if the angle of the road is less than 30 degrees, then delete the edge. Okay, so that's the conditions that I want to add here. So let's do that. To do that, let me think how I can deal with that. And there's a chance that I mean this edge and this edge is being connected at one point, so I think it will be easy to check the angle. But some for example, this edge and this edge is not connected, but if it's too close enough, and if the angle is close to less than 30 degrees, that could also be a candidate to be deleted as well. And this one as well. So I need two conditionals. One is the angle and one is the distance. Okay. To see if the curve should be deleted or not. And if it's so, then delete it. And I should only delete the newly added edges. In this case, group with the TQ group. So that I don't really need to, I don't delete the original, I mean the already being created edges that's being chosen. I don't want to delete the old road, but I just want to delete the new road, which is going to be a new candidate. So to do that, I'm going to use a primitive wrangle and use some additional coding. Shall we? Let me check how I wrote it. Okay, so first of all, what I want to do is to for each TQ edges, which is currently drawn in red, I want to search for the nearby edges. For example, for this edge, I want to search for the close edges and just check the angles between those. Check the distance and edges between those curves. And so to do that, I kind of have to have a way to search for the nearby edges, and I don't really know the best way to search for nearby primitives, but there is a way to search for the nearby points. So what I would do is to first of all convert each edge into a center point positions and use that point to search for the nearby edge. I guess there's more efficient way to do that, but that's one way I thought it will be effective. So for one of the as a reference, I'm going to convert each line into a middle point by adding a point to that at P for each primitive and remove the original primitive. Like that. And the point number and the primitive number is pretty equal to the original edge. So I can use that information to check which edge is close enough. So I've just converted into a edge to a point. Now I'm going to connect it to a second input of this new primitive wrangle and use it to search for a nearby edges. So I'm gonna use a function called new points, which you can look for a nearby points in specific distance. So from the center point of the current primitive, I'm going to search for some distance. Now again, this could be related to a value of the edge lengths for highway and normal lengths. Now, I'm not sure which one's better, but I'm gonna copy the highway lengths and paste it here. Now this could be a bit too much because it'll be looking for a lot of areas, so in those cases there's a chance that even though the distance is pretty far, the edge is going to be deleted because of the same angle. So that's not optimal. So it needs to be at least less than the 0.1 or less than the normal lengths. So I'm gonna reduce this to additional multiplier. Could be, I don't know, about 0.35, 35%. We should change this later to see what's the best value. Okay, now I should be able to get the nearby points list. Let's check. If I'm really getting it or not. So for each primitive, some of the edges are getting for TQ, for group TQ. Yeah, I need to work for the TQ actually. So yeah, just like these, I have a bunch of edges that are closed enough. And these are the point numbers, but it's also corresponding to a primitive number, so which is pretty useful. Okay, so now that I have these informations, I can loop through all those primitives and check the angle with the current primitive direction. So in order to do that, I also need to get the current primitive directions, which I should have done the same things when I created the edge somewhere right here. So let's copy that part, which is there. This part. This is where I have collected the points from each edge, which only has 2 points, and get the direction by subtracting these 2 positions. Okay, let's copy that, going here, and paste it here. Okay. Now, let's loop through all the new points. Now, when you use the new points, you also using the same input number. Oh, wait a minute. Has to be second input. Sorry. Now, the first new point value of this array is, this is ordered by the distance, the closest distance. The closest one will be the same point as yourself, at the same line as yourself, meaning if you're looking at this edge right now to search, this edge center point is the first candidate from this new point, so you want to skip that because you don't really want to compare the angle by yourself because it's always 0. So to skip that, set the I, starting the I from 1, so that you can skip the first one, 0. Now get the new PTS number, and this is coming from the second input value, but it is also could be used as a primitive number for input 0. So use that to get the primitive points from the first inputs. Just like that. Okay. And get the 2 points positions just like I did here. So let's copy these. I'm gonna name it to npt1, npt2, and pos1, and pos2, and directions, and pos2 minus, and pos1, npt, and pt1. Okay, and npts and npt. Okay, so now you have 2 directions, one here and one here, which is close enough within this search distance. Now next thing you want to do is to compare the angle. So I'm gonna use a cosine, and together with the dot product between the directions and the directions, which will give you a angle between 0 to pi. But actually, what I wanna have as an angle is in between 0 to 90 degrees. So if it's more than 90 degrees, I am going to subtract this angle by 180 degrees, so that it will be in between 0 to 90 degrees, so that it'll be easy for us to compare, to check. So, and this is the radians, so I'm going to convert it into degrees. And if the angle is more than 90 degrees, subtract the angle with 180 degrees, so that it will be in between 0 to 90 degrees. Okay, now if the angle is less than some threshold, could be 30 degrees, then delete it. Let's say 30 degrees, and then in that case delete yourself. And you're going to see a lot of edges being deleted. And okay, hopefully this is fine, and let's check the result. Let's connect this back to here and see the simulations. Reset the simulations. Play it. Now, as you can see, it becomes much better. What's this point coming from? Gonna need to check. But overall, it looks good. Oh, kind of a need to avoid making it grow outside the plane. Forgot to make that conditions. But overall, it looks okay. Now, there are some parts that I still want to fix. For example, like these part, why do I have these? This part is also some not really optimal. I also want to have some connections maybe, like these part, if it's possible. These merging point is also not really clean, so these part I might want to fix it. So these local conditions are the next goal to solve. Okay. But overall looks fine. I mean, much better than the last time, I guess. Okay, let's first fix this border conditions. I don't want to grow over the plane. DK. So which I already have it for the highway. I forgot to do this for a normal road. Okay, so the conditions that I was using should be somewhere. Where is it? It's getting busy here. And oh, this one. Okay, so just need to copy this conditions here and use it for every edge creations. Same for the highway perpendicular edges. So let's add some conditions here. Okay. Okay, so that's one. For the straight edge, you have conditions here, so oops. This is end pass, and you have another conditions here. Okay. Hopefully the name convention is correct. Yeah, think so. Alright. Let's see. Let's check. Going back to a geometry node. Play it. Okay, so it stopped. And what about these points? What's these? Do I forgot something? Is it created here or maybe somewhere right here? I might have added some testing point somewhere. I don't really remember. Search for it. Oops. Maybe not here. Do I have it here? No. Delete garbages. Nope. Intersections. Do I add it here? Okay, let's see. New point. PPT. Maybe this one. Yeah, maybe this one. Okay. Let's check again. Okay, looks good. Alright, now that looks good. Now, I don't really like these conditions. I kind of want to touch it. I mean, I don't want to intersect it, but at least it should touch it. to connect with the other end. That's the optimal conditions that I would hope for. So let's see if I can do that. And what's the other conditions that I want to fix? Yeah, pretty much, well, those isolated islands, I don't know how it's been created. Like these, that's also not good. And so on. Okay, so let's see how I can fix it. Let me look at how I deal with beforehand. Well, let me see. Let me go inside the solver first to see how the edge is being created over time. Let's change this to red. I don't really need the highway, but I need to check the TQ. Okay. So somewhere around here, right? So I am guessing because of this deleting conditions, this is maybe a bit too strong as a conditions to delete based on the angle. So let's fix that, shall we? Okay, so what can I do? First of all, I could reduce the length to, I don't know, like 0.2. Let's see what happens. Now I am starting to have a lot of intersections like these, which is still not optimal. I mean, this is a bit too noisy. Let's say 0.3. Now a little bit better. Okay. Yeah, a little bit better, but I don't know about these conditions yet. Let's say 0.25. Okay, close to optimal. Yeah, starting to connect. There are some isolated line, but it's fine. Now this is a bit funny. How does this create it? But overall, it's not that bad. There are some points that I might want to fix, like these lines. Like these conditions not clean. What's this? Isolated lines and so on. So let's check those parts. Okay, so let's bring this to here. Color. Oh, not here. Right here. And check the timing. Okay. So probably this is more than 30 degrees, so that's why it's being kept. And somehow these guys are still based on the rules, so that's why it's being kept. But so I need to have some additional local conditions to delete some of the unwanted result, like these small like lines and so on. And especially if it's isolated, how does this happen? What was it like before? Okay, so this was the original conditions. So this was pretty noisy from the start. And because of this delete by angle code, the whole set was being deleted and these islands are being left out by itself. So let's just give additional conditions to remove the isolated lines, which isn't that hard to check. Or should I fix the angle part? That's the question. I mean, you could go both ways, I guess. Fix the angle part or just delete, just make this result okay to yourself and just use the result and fix the later part as a post process. But let's see how I did previously. I mean, I'm doing the pretty much the same things that I hear, so I guess I'll just delete the isolated line for now. Okay, so to do that, you just need to check each primitive, and if each point is neighbor count is equal to 1, then that's isolated, so that's the one you want to delete. I mean, is there a chance that the isolated world happens? Maybe inside a private area, but nah. So remove the isolated lines for each primitive, get the prim points. I mean, similar to what I have here. Just gonna copy it. Now, I don't really need this one, but I need to count the neighbors for each point. So neighbor count, neighbor count. And if neighbor count 1 is equal to 1 and neighbor count 2 is equal to 1, then that's an isolated line. You don't want it. Okay, now it's been deleted. Okay, what else? What else can I give? Well, let me check. Let me go back to the code that I have previously and see what I did and if I'm doing correct for creating edges as well. Yeah, I guess it's correct. Now, let's see. So I'm stitching, removing the... Okay, and also removing the angle curve with the same function. Yeah. Okay, I have additional code in the previous code that I created to delete the too short curve. for TQ group. Okay, let's see if that's gonna work. So create additional primitive wrangle. Oops. Remove short length edge for TQ curve. And the conditions that I need to check is whether okay, so I need to check which curve that I want to delete, right? So let me see. If I have an edge like these and it's short enough, maybe I can delete it. Is that what I did? Let's see, let me see. So yeah, if the edge is isolated, I mean if there are no connections like these and if the length is small enough, then maybe I can delete it. If it's long enough, then there's a chance that it could be extended to connect to other places, but if it's short, might be better to delete it. So let's do that. So in order to check that kind of conditions, I need to see if one of the points has the neighbor count is equal to 1, and also check the length. And do I have the length informations? I did use a perimeter. Okay, so this should be giving you the length information, so let's use that. I am going to copy this and okay, so let's count the neighbor, which I already have it, so let's copy this. So if n count 1 is equal to 1, or n count 2 is equal to 1, and the perimeter is less than some threshold, then delete it. Again, this could be related to something like these. Okay, well, first of all, let's have this highway line length as a base. And for this one, let's say 0.35. Okay. Now let's see what will happen. When I play it, okay, now starting to see a little bit better result. I don't really know about these conditions yet, though for a lot of places it looks better. I mean, probably this is longer than 0.35, so that's the reason why it's being kept. And yeah, overall, there are some positions where it doesn't look good. What's this? But overall, I guess it's fine. Now, one thing I'm wondering is, it's pretty much same as I have as a things that I created, but one thing I want to add as a condition is whether I could introduce some way to connect these cleanly. I mean, there are some connections happening somewhere, but I mean, I could still see some divisions, especially those places. And what's this angle line here? So there are a bunch of places that could be fixed a little bit more. And what is happening here? It's funny how the road changes. Yeah, so should be more places to fix for sure. Okay, so but I'm already done what I have from a previous file, so from now on I just need to look for the new rule and see if I can do that. If I cannot, then I'll just skip it, but let's try. It's since I have some time here. The way is to check the color where it's been expanded and see if I can fix it in some timing. So let's say I wanna, what's the most part that I wanna fix? I don't know, maybe the connection first. It doesn't really look that bad. Maybe those part. When you have what's happening here? I'm wondering why I don't have an extended curve right here. Let's check that. I might be having right here, but it's being deleted at some point. Yeah. So till here I do have a curve. Okay, now the crossing curve has been deleted at some point. That's deleted by this one. Okay. And if I'm looking at these curves, I am guessing that these curves been deleted because this point, this line and this line's distance is close enough, I mean less than this 0.25. So maybe that was the reason. So if I set this to 0.2, is it gonna be deleted? Kind of guess I need to reset this. Play this back again. Okay. Alright, so this is where I have it, and okay, now it's using I am having a different curve right here, which might be the reason to be deleted together with these curves. It's pretty hard. It's pretty hard to control. Now I could add additional conditions to delete angle to skip even if the distance is too close, if the point is sharing, but that shouldn't be the case. I mean, if you're sharing the same point, there is a chance that I want to delete it, like these points as well. So, okay. Forget about it. It's pretty hard. What about introducing the conditions if you have more than 3 neighbors, like for this point you have 1, 2, 3 neighbors. For this one, this point you have only 1 neighbor. So if one of the point has only 1 neighbors, then and meets with these angle conditions, delete it. Not sure if that's gonna work. Well, let's try. So we have a 2 points, the directions, and these are additional 2 points. And what I want to do is to count the neighbors for each of those points. So let's count it. Maybe you could only look for yourself. Yeah. So this is fine. And let's try to keep some conditions and count 1 is equal to 1, or that might not be good. It's going to keep a lot of curves left. That might not be a good conditions. Let's just test. If not, I'll just delete it. Okay, no. Obviously, that was a bad conditions. Okay, forget about it. Where was I? So you do need to look for a kind of a good local conditions, how you can solve the issues you find it as an issue. I mean, it's really up to you how you feel with the result, I guess. I mean, overall it looks fine. I mean, if you look close enough, there are some things I still want to fix. And I'm wondering why this curve hasn't been deleted with the conditions that I have here. I think it's short enough. Let's see why. At least I wanna just delete these. Okay. And so let's check the length of this curve. Where did it go? Okay, right there. Is the perimeter. 0.015, which is supposed to be smaller than 0.35 multiplied by 0.1, so why it's not being deleted? Where is the... Forgot to write it. Okay. It's my mistake. I thought I wrote it. Okay, so it's been deleted. Okay, let's just check. Okay, well, overall looks... well, if you look close... There are things that I still want to fix, but just gonna... I mean, it's all pretty much up to you how much you want to add as other local conditions. Let's say for now it's okay, and what I want to do as a final touch is to kind of merge the three-dimensional landscape together with the 2D road. I mean, it's just a merging. It's not that hard to do. You have a 3D shape right here, so let's color this with the primitive. Let's make it blue. And one thing I need to do is to test all the parameters to see what kind of difference do I get. Okay. And okay, well, I seem to have missing a highway group at some point. Yeah, it's been overwritten by the normal road. That's not good. Okay, let's go back to check. Let's go back to fix. I am guessing it happens when you are doing like convert line and so. So before yeah, I'm guessing it's happening right here. So what's the best way to deal with it? Just get the highway. Now currently it's being trimmed, but what I want to do is to transfer the group to this convert line to by copying the highway information from here. Or should I do it later? Maybe I should do it somewhere around here. And I forgot to fuse the curve. Maybe I should do it somewhere. Where should I do it? Somewhere around here. Okay. So in order to copy the group, these are just removing the lines, so I don't really need it to do here, but maybe somewhere around here. So let's connect this here and get the highway information. Okay, since this is coming from the different input, I need to give another XYZ distance. Okay. Okay, and in group. Wait a minute, I gotta make sure that distance is small enough. So, and the second input is just the highway group, so I am assured that this is all highway, so I just need to check the distance. Then set prim. Right, or maybe I can just use this condition right here. Okay, hopefully this will fix the highway grouping. Let's check. There you go. Why do I have a duplicated? Okay, it's just I just moved it upward. Okay, so looks good. All right. And the next thing I want to do, what's this? Next thing I want to do is so if you connect these together, there's a chance that the highway will go across the mountain, so I'll just give some functions to like create a tunnel, or just give some cliff so that the highway will have a straight line. Highway will find a way go through this mountain. Okay, I mean, if it's just a tunnel, you could just make pipes and do a boolean if you're going to engrave it. Then maybe I could give some erosional functions right here. So let's try doing that. Okay, so what I am going to do, going to check, I'm going to make the height of the mountain a bit lower where you have a highway curve or any other curve like road curve. What's this? Why it's been splitted? Huh. Okay. Unwanted conditions happened. Okay. It's been deleted. Probably because of the angle conditions. Now I gotta make sure that this geometry at this curve should not be deleted if it's highway. So and imprim group let's see. Okay, suddenly it becomes really heavy. Why is that? Oh. I think I'm having some issues. Suddenly it becomes really slow for some reasons. I don't know why. I just added this one, right? Is this the problem? I don't know. Let's see. Save it. Okay, so this is not a problem. So why did it not work? Huh. TQ. If m prim group highway prim num is equal to 0, then you can delete. Is this gonna be a problem? But it does seem to be a problem. Okay, so there is a chance that you're going to have a duplicated highway. Huh. What's this? So this is the conditions where I am having some problem. Oh. Why am I getting this as a highway? Maybe because of the conditions that I set is not good in order to copy the highway group. Right there. This should be the problem. So okay. So where did this come from? Come from here. And created as a highway, is it? That's weird. That shouldn't happen. Run from no constant highway red. Oh, so yeah, shouldn't happen like that. Is it a TQ? Yeah. So somehow the line that's being created like this is set as highway. Why? Why is that? And it's coming from here, seems like. Okay. Why I'm guessing this is still the problem. What if I make this things small enough? And this is also small enough. Would that solve the problem? Let's see. Nope. Eesh. Okay, well, I'm gonna have to think about this a different method. So let's forget about copying the groups in this way for now, and let's also not give a conditions away. Let's keep these conditions and see what happens. Okay, so that's fine. That is fine. So the problem is how can I keep the highway group probably after convert line and so on. And I can see that some of the edges are being deleted as well, which I also wanna avoid. Yeah. Also, when you use a fuse like these, I'm not sure if I wanna do the snapping to near points. Well, doesn't really make much changes. Okay, so I gotta think of how I can preserve the group, highway group. How does this... Okay, I gotta check how it's been created, how it's being converted. When inside, so yeah, so this line has been created, which is close to a highway, and because of using the fuse, it's being lying on top of the highway as a line, and after using the convert line, it's been merged with the highway line, and somehow because of that the group has been removed. Okay, so that's the reason. So keep group order. So if the highway group is if the group order is that the highway is coming first and other road coming later, is that going to solve it? Not sure, but keep group order. What does this mean? When enabled, lines are ordered by according to the group parameter instead of point numbers. Group parameters. Well. Okay, well, maybe I should copy the group after all, but didn't really work last time, did it? Let me just try again. So instead of getting from this one I'm going to check from the original input. Would that solve it? Well, this problem is fuse node is going to change the point position of the highway as well, so that might be a problem. Yeah, that might be a problem. And I don't know, let's just test. Let's keep this 0.00, 0.01 for this one. Okay, let's see. Let's see what happens. And oh, nope, nope. Something has happened. No, it's not working. Oh, it's pretty hard. Those small conditions. Well, let's go back to where I was deleting by the angle and remove this highway condition. Okay. And let's go back again and see. Okay, make this 001. And I am okay. Now let's see where does this color come from? Okay, is this all highway? Oh, what happened? This is not working. Ah, okay. Now it's not working because I kind of have to get the highway group from the third input. I forgot to do that. Okay. Now, I'm guessing the copying failed right here. So, it's pretty hard than I thought. Okay. So this convert line should be only using the same group, either highway itself or non-highway, but that's going to mess it up. It's pretty hard. How did I do beforehand? Let me just check, going back to how I did, because it's used to work. Right. first of all, let's try to sort the primitive so that the highway always comes first, and normal curve, normal line always come later. So to do that, I'm going to have a attribute called t as a time is an integer value which defines the speed or time delay of the edge. Okay, and when you create a new extended road, what I would like to do is to always make sure that the highway highway always have the small value in terms of t. So if it's set as highway, set the t as 0, which is the default value, so that's fine. But if it's not a highway, if it's a normal road, then in those cases you might want to make it as a make the t value a bit bigger. So let's see, this is what I'm creating. So set prim attrib and the current t plus 5. Okay, do the same for all the other edges. Okay. Huh. This is where I was creating. Okay, so else. Okay, how's that? And sort the primitive based on the attribute t. Let's see what happens. Let's comment this out now. What I'm wish for is that convert line will use the first group, which is the highway group. Nope, didn't. Huh. I'm wondering why it worked for my previous setup. Maybe it wasn't working, I don't know. Well, it does, it is working. Okay. One reason is because you were not having the line that's trying to overlay with the highway, so I need to check how I avoided it. Currently, the problem happens when a road curve trying to overlay on top of the highway. So that shouldn't happen. Okay, so let's see what I did. Okay, I'm gonna check from the first step. So I have the sort, I have the branches being created. Let's see if I had any conditions to create the branch. Okay. So One thing I seem to have missing. There is one thing I'm missing, but I'm not sure if that's the reason. What else? Okay. Perpendicular. Okay, let me try to add one function to a extend row network, which I don't think is the reason, but okay, so what I was writing is that I'm introducing a new functions to create a new point to the positions that I define, and if it's close enough to some of the point nearby, then snap it to that position. That's all. But that's really not the case here, I think. So if it's close enough, instead of creating a new point, just return the point number. Else actually create a new point if it's far from the other points. So that way you can kind of reduce using a fuse node process, but not sure if it's gonna mean anything. So the new point is being created here, so instead of using add point, just use new point. Like that. Oop. New point. This has to come beforehand. Okay. Well, let's see the difference. Okay, doesn't really see any difference. Still have some same problem here. So let's see what else I need to do. Okay, and after I have created the branch, I have created the edge network. I have used the fuse. That's same. I've used the convert line. That's also same. And intersection stitch. Yeah, those parts are pretty much the same things. Total copy. I didn't really have this third input, but just commenting out right now, so it's the same thing. No. Let's see if I seem to have a clean here, but I don't think it will change that much. Nope, it's not really changing. So that's not the case. Well, let's try. Instead of copying from the second input, third input, let's just try to copy from the second input. That's what I was using previously. Okay. Seems like this was the conditions that I have. And everything else is pretty much the same. I think gotta make sure that this is running on top of the queue. Oh, remove, okay. This is fine. TQ. Okay, right. Now, the problem happens when the normal road network try to go over the highway. And that's what I need to kind of avoid. So should avoid within here, I guess. And those curves are created somewhere around here. Right? So I need to make sure that the edge that's being created is not on top of the highway. So maybe I could add some conditions for that somewhere around here. And so I could, let's say, get the middle point of this edge, which is in between P pos and position 2. And check with the intersection, check with the distance with the highway, the current highway. So and XYZ, just need to use a group. So origin, prim group, vector, okay. So the second input should be a group. And if this highway distance is small enough, no, should be higher than the value in order to create a curve. Then you can create a road. So it's if it's far from highway, you can create a road network. So that should be it. And let's see. All right, now I am getting it. Okay, finally. I don't like it. Let's just fix it later. Okay, so what to do is making these eroded with these curve. So for these mountain shape, I'm going to make a point wrangle and check the curve from solver, and based on the distance to those curves I am going to erode the mountain. So first of all, let's get the flatted point position of each point on the mount for the mountain, which is x 0 z. So I'm just going to flatten the height to 0. Then calculate the distance between the curve from the second input. Okay. And if no, also let's create a kind of a scale function to see how much it affects, how much the distance will affect to engrave or erode the mountain. So using fit functions for the d from 0 to some threshold distance, I'm going to make for the center part make the height 0, and for the outer part make it original scale. Okay, let's give some distance value, and you could also apply some power functions to this one. Not sure how it's gonna change. Let's start with 1. Then update the height of the mountain by scaling the height by SC. Okay, well, what did happen? You can see that if the highway is crossing the mountain, that you're kind of engraving or having erosions on that part. If you combine these two, see some effects here. Now if you increase this power functions, you're going to see some erosions like a cliff, artificial cliff. And there you go. So this is eroded distance. Okay, so seems to work. Now let's see what happens in the animation. So it's kind of a engraving like a tunnel. Okay, seem to work. Let's try to change the landscape height a little bit. Where did I do that? Right here. How's this? Let's see what happened with these. Okay. Yeah. Not bad. Okay, so overall it looks good. For the final step, I mean, this is pretty much completed, but maybe I might want to have a bit of control over the local conditions. See if I can optimize this a little bit more. Let's check what I have previously. I mean, I guess it's a good idea to just upload two files, because it seems like it's a bit different. So this is the result that I have previously, which looks a bit different from what I have right now. I'm using the same numbers, but yeah, somehow this looks better for some reason. I don't know why. Maybe if I change the conditions, that might change. Let's change the height field. Let's change the condition to give him some offsets. Let's see what this. Pretty similar to what we have here. But well, I don't know if it's better or not. I mean, I do see some gaps here and there with this one as well. So, not sure. Let's go back to where we were working on. One thing I need to do is to check with different parameters, so let's organize this a little bit. I have a bunch of parameters, especially when you create a extensions. So probably I didn't really need it this sort, but anyway. Okay, so I have a bunch of parameters right here, so let's bring this to a controller so that I can control from outside a solver. Let's see, going inside the solver, and I gotta name it so that it's easy to understand. Let's give a separator between highway and normal. And so this is highway straight angle 15. Okay, highway straight straight offset angle. Okay, highway perpendicular offset angle. It's a long name. Highway perp offset angle. Highway perp offset angle. Well, this has been used for the normal one as well, so maybe I should go back and create a normal one as well. Okay, highway prov. This is highway per probability. So in order to create a perpendicular branches, or let's just call this branch probability, more like it. And this is also branch. Okay, and what's this? Highway population threshold. Okay, so highway population threshold. Highway population threshold. Okay, seed. The random seed is a global parameter, so let's give another separator here. High H perp prob. Well, what's this? This is the. Wait a minute. Highway probability was the probability that the crossing the. Okay. Let's give this a branching probability, which is 5%, and out of 5%, the highway prob is gonna be used to determine whether it's gonna be normal or highway. So this naming should be fine. And the normal pop thresh. Okay. Normal population threshold. So many parameters. And normal probability, which was for branching. Okay, so normal branch probability. Wait a minute, in that case, this is for the highway. So, oh wow, it's so hard to name it. So this is, okay, let's bring this here. So this is highway. 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 So this is the branching probability. So, no, I'll just go with this. So hard to name it. Okay, well, let's go for this one now and apply. What else? I have these snap distance. This is also important, I think. So snap dist. This is also automatic. This is fine. This is also fine, I think. Just deleting the garbages, so that's fine. It's also fine. Okay, angle. So this is also important. Angle. Remove angle threshold. From 0 to 100. Multiplier. Okay. Remove angle search distance. Okay. Search distance multiplier, but I'll just go with this. Okay, and remove isolated line. That's an automatic. Okay, another threshold. This one is remove short lengths with one neighbor. Okay, so okay, what else? That's it. Okay, let me just check again what I have as additional stuff. I guess that's it. Or wait a minute, there is one thing that I could introduce. If you have... I'm missing one thing. If you have an edge which is inside a TQ group, it's inside a TQ group, let's check. And if that edge, check the neighbor count of this edge, or this one and this one, and if the edge count, I mean the count of the neighbors, either for starting point and the end point, if it's less than 2, remove it from the TQ. Huh. Is that gonna solve it? I'm not sure why I made that conditions, but let's see. Let's create that conditions. So, for TQ group, as always, I'm going to get the points from the primitive, which you get 2 points. And I'm going to give a rim flag. Loop through all the points and check the neighbor count for those points. And if the neighbor count number is less or equal to 2, then make the remove to 0 and break the for loop. And if the rem is equal to 0, then set prim group t q prim num to 0. So I'm not removing it, but I'm just removing from the group so that it's not going to be used as an extension base for the next loop. That might going to solve something. Let's see what happens. Okay. Apply, accept. Oh, doesn't didn't really grow. So it's a failure. Okay, didn't really work. Let's see why. So till here, it's fine. Here, yeah, I just removed. Obviously, that's not correct. So why did I write it like that? And why did it work? Let me just go back to the one that I have previously and see how did it work. So same as trying to color the TQ primitive red, and after having this, why is it being preserved? Am I writing differently? Oh, the condition was wrong. If the rem is equal to 1. Oh, I see. I see. So this means I should only keep an extension curve when you have a single neighbors. Okay, that makes sense. Okay. So this condition should be equal to 1. Okay. Now let's see what happens. Okay. Plate. And yeah, seems like I do have some clean result. Not sure how much it's affecting. Anyway, not too bad a result. Now let's try changing some parameters and see how these parameters will change the result. Okay, so let's go to here, controller, bunch of parameters. Now obvious changes could be done by changing the seed. Which sometimes create a branch for the highway, sometimes not. Yeah. Okay, what if I want to have more chance so that highway will create a branch? You might want to increase branching probability or highway branch probability, maybe this one, to 30%. So now you have more chance to have a highway branching, going to more directions, giving you more infections. Okay, not bad. Okay, what else? The highway branch offset, these are used to create some angles, bends for a perpendicular or a straight road. So if I made this to 0 and 0, it will be more artificial road, I believe. Yeah, more like a fractal shape, which you see a lot in, I don't know, examples. It's not fun at all. If I make the straight offset to 15 degrees, the game is a bit more organic, and although the crossing perpendicular direction is offset is 0, so it's more artificially straight. And you have some conditions there and there. Okay, so I guess these values are important to make it a bit more organic. Yep. Okay. What else? Snap distance. What if I set it to 0.02? You're going to have more kind of a not clean angle connections more. If I reduce this to 0.005, yeah, not bad, not bad. Maybe this is better. Yeah, well, I'll just reset to 0.001 for now. And remove angle search distance. Okay, so this was to remove the angle, and this is the search distance looking for the closest curves. Probably 0.25 is good, but if I make it 0.5, you'll see a lot of curves being deleted. That's a lot of deletion. It's not good. if I make it too small, you see a lot of intersections starts to happen. It's not really good. So maybe somewhere around here. Oh, was it 2.5? Somewhere around here is I guess a good number. Or 3. Yeah, not bad. I mean, you start to have some gaps between the worlds, so if there is still a connection, that's fine. Well, it's up to you. And this is the angle threshold. If you make it more higher, then you're going to delete more curved edges, which might be good for some cases. And if I make it to 5 again, back again, not bad. Huh. Not that bad. Let's make this 45. Okay. And remove short length threshold. This is to remove a really short edge length. If I set it to 0.5, start to see a less road created, but having a bit more bigger areas, so that might also be interesting. Yeah. Not bad. Not bad. Let's make it 4.4. 4.45. Okay, yeah, I like it. I think I like it. Alright, then highway lengths. This is the length of the highway. I don't really need to change these part for this scale. But if I change this to 0.2, if I make the normal length to 0.1, what would happen? So you get bigger areas, right? It's pretty obvious. I'll make it back to 0.1 and 0.05. What else? So I tried these. I have tried these. And branching probability. So by increasing this, you have more chances that highway will give you more branches. What's happening? Okay, so if I increase this to 0.2, 20% of chances you get branches. Going to see a more branches happening. Might be fun. This back. And highway population threshold. Well, this doesn't really do much because it's pretty much 0 to 1, so yeah, doesn't make any much changes. So normal lengths, normal branch probability. So if you make this small possibility to make a branch, you're going to see less square shape. Yeah, just like that. If I make it pretty much close to 0, you're just going to get a straight line. And that's not that bad. I mean, pretty still interesting. Doesn't really look like a road anymore, but yeah. And let's see. 0.35. Yeah, I'll go with this number. Okay, and threshold doesn't really make any changes. Okay. What else? Do we have any other parameters? What's this? exclude curve with something like that. Okay, so I guess I have promoted all the parameters that I could control with this setup. Yeah, that was a long way. Well, it's already 3:20 a.m. But I guess I am kind of satisfied with the result. Yep. I mean, this is just a 2D and I'm still missing like houses, buildings, silhouette at least. Maybe next time. Yeah, so for now, this is it. So this is, well, maybe you wouldn't call this L system based, but it's more of a fractal based system road network creation. I mean setup for road network. I hope you liked it. I am going to upload this file so that you can download from the link in the description page of this YouTube later. Okay, as soon as I finish the live stream, I'm gonna upload it. Okay, so that's it. If you compare the one that I did with the code explained here, you might see some differences, but the base idea is coming from here, so that's a big thanks to him. Okay, that's it. Thank you very much for listening, watching. I'll finish the live stream for tonight and I'll see you next week with some different stuff. Okay, let me know if you have any questions or feedbacks or anything. I'll try to answer it as much as possible. If not, I'll end this live here. Okay. Yeah, you could. It's pretty interesting. I mean, hopefully I'll be able to use this system to actually create the city, not just in 2D, but maybe with some landscape and road thickness and houses and stuff, but maybe not today because it's too late. At night, it's 3:20 a.m. in Japan time. Should go to sleep. Okay, I guess I don't see any questions, so I'll just finish it tonight. Thank you very much and good night. Just in case someone asked for the original link, so I'll paste it here. Okay, that's it. Thank you very much, and I'll also paste the reference link to the description page so that you can also check that out. Alright, good night and thank you. Let me just